Good morning, students. Today we are going to discuss characteristic polynomial and characteristic equation. How to find characteristic polynomial and characteristic equation. Come on, keep the heading. Characteristic polynomial characteristic polynomial. Next, characteristic equation. Characteristic polynomial, characteristic equation. Come on, write the definition of characteristic polynomial first. Characteristic polynomial. If A is a n by n matrix, if A is a n by n matrix and lambda is a scalar, then determinant of a minus lambda I, then determinant of a minus lambda I is known as characteristic polynomial, characteristic polynomial. Come on, say once. If A is a matrix of order n by n rows and n columns, and lambda is a scalar, then determinant of a minus lambda I, is known as characteristic polynomial, Come on, write next definition. Characteristic equation. If A is a n by n matrix, and lambda is any scalar, is a scalar or is any scalar, no problem. Lambda is any scalar, then determinant of a minus lambda I equal to 0. Then determinant of a minus lambda I for identity matrix, determinant of a minus lambda I equal to 0 is known as characteristic equation, So, very simple. Characteristic polynomial and characteristic equation. If A is a n by n matrix, then determinant of a minus lambda I, that of a minus lambda I is known as characteristic polynomial, and if that of a minus lambda equal to 0 is known as characteristic equation. Just come and copy it. Yes, and now problem. Over, no? Yes. Come on. Find the characteristic polynomial. Find the characteristic polynomial. Come on, right? First question. Find the characteristic polynomial. ST I forgot. Find the characteristic polynomial, comma, characteristic polynomial, comma, characteristic equation, characteristic polynomial, characteristic equation, and eigenvalues, and eigenvalues of the matrix, Find the characteristic polynomial, characteristic equation, and eigenvalues of the following matrices. Come on, right? A bit. 3 minus 2, 1 minus 1. 3 minus 2, 1 minus 1. B bit. 2, 1 minus 1, 4. 2, 1 minus 1, 4. And C is 3 by 3 matrix. Minus 1, 0, 1. Minus 1, 0, 1. Minus 3, 4, 2. Minus 3, 4, 2. 0, 0, 2. 0, 0, 2. Yes. Here we have to find characteristic polynomial, characteristic equation, and also eigenvalues. Yes. Come on, we'll do one by one. Yes, come on. Once see the question once. Find the characteristic polynomial, characteristic equation, characteristic CHARA, CT, ER, IST, IC. CHARA, CT, ER, IST, IC. Characteristic equation and eigenvalues of the following matrices. 3 bits we are doing here. Okay. Yes. Now first bit. Come on, right? First, given A equal to 3 minus 2, 1 minus 1. First we are doing first bit. A equal to 3 minus 2, 1 minus 1. Come on, right? Number 1. The characteristic polynomial is the characteristic polynomial. The characteristic polynomial is that of A minus lambda I. The characteristic polynomial is that of A minus lambda I. Come on, right? Implies A minus lambda I. This we have to find. That of A minus lambda we have to find. Come on, right? Matrix A. 3 minus 2, 1 minus 1. Minus lambda times of A minus lambda I. Write the matrix A first. 3 minus 2, 1 minus 1 minus lambda times of identity matrix 1 0 0 1. Determinant of, that's all. So simplify it. 3 minus lambda into 1 minus lambda minus 2 minus 0 minus 2 1 minus lambda into 0 1 only minus 1 minus lambda minus 1 minus lambda 3 minus lambda minus 2 1 minus 1 minus lambda. Simply we have to find determinant AD minus BC equal to, come right here, implies determinant no ABCD AD minus BC 3 minus lambda times minus 1 minus lambda minus of minus 2 into 1 AD minus BC AD minus BC implies, simplified, 3 into minus 1 minus 3 3 into minus lambda minus 3 lambda minus lambda into minus 1 plus lambda minus into minus plus lambda square minus into minus plus 2 1 ja 2. Simply you are getting lambda square, coefficient of 2 is degree 2 is lambda square, we have degree 1 minus 3 lambda plus lambda minus 2 lambda minus 1. This is characteristic polynomial, lambda square minus 2 lambda minus 1. So come and copy it. Yes, characteristic polynomial is over. Now next, one more we have. We have to give characteristic equation, nothing but det of A minus lambda is equal to 0. The characteristic equation is A minus lambda I modulus equal to 0, nothing but det of A minus lambda equal to 0. Det of A minus lambda equal to 0 implies, already we have det of A minus lambda I, lambda square minus 2 lambda minus 1 equal to 0. This is characteristic polynomial. Number 3, we have to find characteristic values. Characteristic values or characteristic roots, I and roots all are same. Characteristic values, we have to find characteristic values, we have to find, or characteristic roots we have to find. Degree 2 quadratic polynomial, quadratic equation, so 2 roots will be there, the 2 roots we have to find it. Come on, right, lambda square minus 2 lambda minus 1 equal to 0. Lambda square minus 2 lambda minus 1 equal to 0. We are not getting any roots here. Minus 1 minus 1 minus 1 minus 2, okay, but wrong only. So we are not getting any roots. So we have to find lambda equal to minus b minus of minus 2 minus b plus or minus root over b square minus 2 whole square minus 4 a value 1 and c value is minus 1 by 2a, 2 into a value is 1. Here a value is 1, b value minus 2 and c value minus 1. So lambda equal to minus b plus or minus root over b square minus 4ac by 2a. Lambda equal to minus into minus plus 2 plus or minus root over 2 square 4 minus into minus 4 root 8 by 2. 2 plus or minus root 8 by 2 Yes, I'll solve it. Simple, still I can solve it. 2 plus or minus root 8 by 2. So, lambda equal to 2 plus or minus 8 I can write 4 2s are 2. 4 2s are 8. So, simply I can write 2 root 2. 2 root 2 by 2. Take 2 common. 2 times of 1 plus or minus root 2 by 2. 2 2 cancel. So, simply the roots are lambda equal to 1 plus root 2 and one more 1 minus root 2. The characteristic roots are, or the characteristic values are 1 plus root 2 and 1 minus root 2. Therefore, the characteristic values are the characteristic values are 1 plus root 2 1 plus root 2 comma 1 minus root 2. That's all. Let's come and copy it. So once I'll explain measurements. Actually is given A is a matrix is given. A is a matrix of order 2 by 2. A is a matrix of order 2 by 2. 3 minus 2, 1 minus 1. The characteristic polynomial, simply we have to find determinant, we have to find for A minus lambda I. A minus lambda I. A matrix already is there. 3 minus 2, 1 minus 1 minus lambda of identity matrix 1 0 0 1. I simplified it, I got this one. 3 minus lambda minus 2, 1 minus 1 minus lambda. Simply I calculated AD minus BC. AD minus BC. Determinant already know 2 by 2 matrix AD minus BC. I did. So that I got lambda square minus 2 lambda minus 1. Now the characteristic polynomial is over. Characteristic equation nothing but equal to 0. And third bit is we have to find the roots we have to find. Or characteristic values we have to find. Simply we have to find the roots we have to find. Degree 2. So obviously 2 roots will exist. The 2 roots are found. 1 plus root 2 and 1 minus root 2. Actually we can't find the roots by factorization. So I went for discriminant form. Minus b plus or minus root over b square minus 4ac by 2a. Therefore, the roots are lambda equal to 1 plus root 2 and 1 minus root 2. Let's come and copy it. Yes. Now, we'll continue. Second bit. Given A equal to given A equal to 2 1 minus 1 4. Yes. You can also try same as previous bit only. You have to find characteristic polynomial, characteristic equation and in values or characteristic values or characteristic roots. All are same only. Characteristic values or characteristic roots you have to find. Come on, right. Here we have to find in values, characteristic polynomial and characteristic equation. First we find polynomial. Come on, right. The characteristic polynomial is the characteristic polynomial is determinant of A minus lambda I. The characteristic polynomial is det of A minus lambda I. So come on. Implies, come on, substitute. What is the matrix A? 2 1 minus 1 4. 2 1 minus 1 4 minus lambda times of matrix you have to write identity matrix 1 0 0 1 modulus nothing but we have to find determinant implies, come on, simplify it, 2 minus lambda into 1, 2 minus lambda Next 1 minus lambda times of 0, nothing but 1 only. Next minus 1 minus lambda into 0, minus lambda minus 0, nothing but minus 1 get. 4 minus lambda into 1, 4 minus lambda. This you have to find determinant AD minus BC. 2 by 2 matrix, no, directly AD minus BC implies 2 minus lambda times 4 minus lambda minus 1 into 1. AD minus BC, AD minus BC, 2 minus lambda times 4 minus lambda AD minus B minus 1 into 1. Come on, simplify it. 2 4 is 8 minus 2 into lambda, 2 lambda minus lambda into 4 minus 4 lambda minus into minus plus lambda square plus lambda square minus into minus plus 1 you getting. So simply quadratic polynomial is lambda square minus 2 lambda minus 4 lambda minus 6 lambda plus 9. This is characteristic polynomial lambda square minus 6 lambda plus 9. Come on, copy it. The characteristic polynomial is the characteristic polynomial is lambda square minus 6 lambda plus 9. The characteristic polynomial is lambda square minus 6 lambda plus 9. Very simple. You have to find characteristic polynomial. Already I explained what is characteristic polynomial. Just determinant we call it a characteristic polynomial. Determinant of 2 by 2 matrix of A minus lambda I. A is a matrix of order 2 by 2, 2 rows and 2 columns. 2 1 minus 1 4 minus lambda times of identity matrix for 2 by 2 1 0 0 1. I simplified it. Now I am finding determinant AD minus BC. I got a polynomial I got. Now I want characteristic equation I want. Simply equal to 0 I have to write. Come on, write. Number 2. The characteristic equation is I think now you can able to see properly. The characteristic equation is lambda square minus 6 lambda plus 9 equal to 0. 9 I have to write. 3 3 are 9 minus 3 minus 3. We got by factorization method. 9 we require minus 3 into minus 3 minus 9. Sorry, minus 3 minus 3 minus 6 minus into minus plus 9. We got product as 9 and sum as minus 6. It is correct. So simply, come on, take you can write lambda square minus 3 lambda plus 9 equal to 0. Sorry, characteristic equation is over. I am finding the roots. Characteristic equation is over. Number 3. Number 3 is we have to find the roots. Now I will solve it. Because it has only characteristic equation in second bit. I wrote only equation. Now we have to find roots also. Come on. Lambda square minus 6 lambda plus 9 is equal to 0. Again same process. 9 minus 3 minus 3. So lambda square minus 3 lambda plus 9 equal to 0. Lambda times of lambda minus 3 times of lambda minus 3 equal to 0. So simply the roots are 3 comma 3. The roots are 3 comma 3. Therefore, the in values are 3 comma 3. The in are 3 comma 3. Come on, find it. Now you can copy it. So, very simple. We have to find characteristic polynomial. We have to find that of a minus lambda I. Simply lambda square minus 6 lambda plus 9 is characteristic polynomial equal to 0 characteristic equation, and we solved. We got the roots also, that is characteristic values. That's all. Yes. Now, two more bits are there, C and D. I will write on the board. Try once. Find the characteristic polynomial, characteristic equation, and characteristic polynomial, characteristic equation, and characteristic roots or characteristic values you have to find as homework. If you have any doubt, in the next class, in the next video, you can see the solution also. Okay? Come on. Once I will write the C bit and D bit once again, do it. Okay? Stop it first. Over? Okay. Find the same only, already we wrote. Find the characteristic polynomial, characteristic equation, and characteristic roots for matrices. Come on, write the matrices once again to understand. Minus 1, 0, 1, minus 3, 4, 2, 0, 0, 2. Minus 1, 0, 1, minus 3, 4, 2, 0, 0, 2. Next, 6, minus 2, 0, minus 2, 9, 0, 5, 8, 3. For these two problems, you have to find it. For these two problems, you have to find characteristic polynomial, characteristic equation, characteristic roots. Here it is 3 by 3 matrix, so you have to consider identity matrix of 3 by 3. 1 0 0, 0 1 0, 0 0 1. So simply consider characteristic polynomial as determinant of A minus lambda I. Matrix A already we have minus lambda times of I for identity matrix 1 0 0, 0 1 0, 0 0 1. For that you have to find the determinant. Of course, you get a characteristic polynomial of degree 3. Characteristic polynomial of degree 3 because 3 by 3 matrix. So you will get a characteristic polynomial of 3 by 3. Then write characteristic equation equal to 0. You will get a characteristic equation, you will get of degree 3. Solve it, you will get the 3 roots, you will get it. Characteristic roots or characteristic values, you will get it. Same as D bit also. Do it as homework. Still, if you have any doubt, you can see in the next video. Thank you.